What is going to be the limit as x approaches 3 for this function? Well, the first strategy we're going to employ is to do direct substitution. We're going to directly substitute into this function. We're going to say, well, if x approaches 3, well, what's going to happen when x is at 3? What's going to happen when x is equal to 3? Well, just looking at the function, we'll notice in the denominator, you're going to get 3 minus 3, which means you're going to be dividing whatever the top is, the numerator, by 0, which is an illegal function. So we cannot directly substitute into this function the limit of x equals 3, or just simply x equals 3. So this means we're going to have to try something else. Well, maybe we can try factoring or reducing something in the numerator so that way it cancels with something in the denominator to change our denominator. That way we're not dividing by 0. Whether that's going to be to get rid of the 3, get rid of the x, or simply going to be to get rid of the whole denominator expression. So let's go ahead and think about that. The first thing we should notice in our numerator is that 5 or negative 5 and 15 are both multiples of 5. And similarly, we should notice that 2 and negative 6 are both multiples of 2. So what does this mean? Well, it means that we can factor out of negative 5x plus 15, we can take out 5. Similarly, for 2x³ minus 6x², we can factor out a 2. However, we can do more than just factor out a 2 here. Notice that both of these expressions have an x, which means we can factor out how many x's? Well, we can take an x once for sure, but that would still leave us with an x on both sides. Well, we can factor out 2x's, right, and x squared. That would get rid of the x squared here, and we can take out an x squared here, but it'll leave an x here. But then our two terms won't have both an x. They won't have something in common. So there we go. We can now factor out here 2x squared and a 5. So let's see what that's going to look like. There we go. It's going to look something like this. Something I do want to note is I ended up factoring out not just a 5, but a negative 5. Why did I factor out a negative 5? Well, of course, they both have a multiple of plus or minus 5. But why did I choose the negative? The reason I chose the negative is because I want to have the same bracketed item here as I do here. If I didn't factor out a negative 5, I would have had a plus here, and that would have been very annoying. The point of this is to be able to factor something out here to cancel with the bottom. So I wanted to get x minus 3 both times. And to do that, I had to factor out the negative of 5. So there we go. Now this leads me to my next point. Now we can factor out something again. Notice that we have two things that are going to be multiplied by x minus 3. We have x minus 3 here and x minus 3 here, both multiplied by something. This means we can now factor out x minus 3 out of the numerator, and that's going to look something like this. So there we go. Factoring out x minus 3 in the expression up here leads us to a function that looks like this. Now remember, this function here is the same as this function here. They just look very different. But what do we notice? Well, if we put brackets around our denominator, which we can always do, well, we notice that the numerator x minus 3 and the denominator x minus 3 both cancel, right? This divided by that is just going to give us 1 up here, which means it's going to be 1 times this expression, so we can just ignore the 1. We're going to just be left with this expression up here, 2x² minus 5. Well, let's go ahead and think about this. Since we're saying this expression is the same as that means we can now retry our direct substitution. Can we just plug in x equals 3 into here to see what happens when this function approaches 3? Well, let's go ahead and give that a shot. We plug in 3 where we have our x that's left, and we're going to find, well, 3 squared is going to equal to 9. 9 times 2 is going to be 18. It's going to be 18 minus 5, which is going to be 13. So we found that the limit as x approaches 3 in this function here after doing some algebraic operations is going to be 13.